Hello, so today we are talking about combining discrete random variables. In previous videos, we've done SOCs for discrete random variables, we've transformed discrete random variables, and today we're combining. So we're slowly building on each video and on each topic that we cover. So if you have not watched the other two, please go back and watch them. They're all part of section 6.2 in your textbook. You can also go there for more examples. So let's see what combining discrete random variables looks like. When I combine random variables, the first thing I'm going to combine are my means. So the means of discrete random variables, we notate as this mu, or as that U with a tail, or kind of a weird looking M. So if x and y are random variables, so we defined x and y to be some random variable, then the average of x plus y, or combining those random variables, is just adding the means together. So the mean or expected value of the sum of several random variables is the sum of their means. So let's just say I wanted to do x plus y plus z. That's a y right there. That would be adding the expected value of distribution x with the expected value of distribution y with the expected value of distribution z. So notice I'm adding the expected value of each of my distributions. Make sure you get this notation when you write down that formula, because I first have to find the expected value of each distribution and then I'm adding them. So this is combining means. If I look at an example, we're going to go back to Linda and her cars. So it says Linda sells and leases cars at a large auto dealership. So X is the number of cars she sells, and this is the same distribution that we've been working with from previous videos. So for the X distribution, which is the cars sold, I found the mean of that distribution to be 1.1. So this is a review of the previous video, how to find the mean of X. Quick overview, I multiplied 0 times 0.3 and then added it to 1 times 0.4, added it to 2 times 0.2, added that to 3 times 0.1. If you're still confused as to how I got this mu of x, please go back and watch SOCs for random variables. Well, it says let y be the number of cars leased. So when you lease a car, you can lease it for like 1 year or 3 years. So it's different than selling a car. So we have a different distribution for it, and I have one error on this page. We're going to cross this out and make this a y, and cross that out and make that a y. So quick little update, this should be y, 0, 1, 2, and this should be p of y. So the probability she leases 0 cars is 40%, the probability she leases 1 car is 50%, and 2 cars is 10%. I know that this is a legitimate probability distribution because all of these probabilities are in between 0 and 1, and when I add this this row together, it adds to 1. So the mean of distribution y is 0.7. So 0.7 are the expected number of cars that Linda leases. So if I want to find the expected number of vehicles Linda will sell or lease, that would be adding together my two different expected values. So the mean of x plus y, which is the expected number of vehicles Linda will sell or lease, that's this notation right here, that's what this means, equals 1.1 plus 0.7, or 1.8 vehicles. So I know that's weird to leave it as 1.8 vehicles. Deep down you want to round that to 2, but we're going to leave it as 1.8. Because as we know, when we find standard deviation, this number and the decimals that it has are super important. So that is how I combine means, which brings me to my first key point. when we combine independent random variables to find the total sum being I'm adding the two distributions together, we find the sum of their means. So I add their means together. Well, what if I wanted to find the total difference of something? What if I wanted to find kind of how one thing may be greater than or less than another? So if I go back to this example, it's the same x and y, and we're going to write that as y, there we go. But this time it says the car dealership wanted to find the difference in the expected number of cars sold and leased. Let D equal x minus y. So it gives me this new random variable, and it says random variable D is going to equal the difference of cars sold minus cars leased. So then it asks me to find mu of D, or find the expected value of D. Well, if I'm finding the difference between two different distributions, I take the mean of one and subtract the mean from the other. So for means, I just do what the problem tells me. It says x minus y, so I'm going to do the mean of x minus the mean of y, which is 1.1 minus 0.7, which gives me 0.4. So the expected difference in cars that Linda will sell or lease is 0.4. So for difference, if I'm looking for D, x minus y, or just the difference in expected values, I'm going to subtract the means. So total differences mean I find the difference in my expected values, whereas total sum meant that I found the sums. So this is only good for means though. If I think about means are impacted by both A and B. So means are going to change with it being positive or a negative difference. Standard deviations and variance are a little bit different. So if I go to combining the variances now, and we're given that same prompt, x and y are independent random variables, then adding them or finding the total sum means that I add my variances together. So I add the variance of x plus the variance of y. But if I'm finding the difference between x and y, I'm still going to add together x and y's variance. So make sure you get these equations down. You need to have these in your notes because these two equations help us refer back to kind of concrete examples when we're given a really wordy problem. So we always add the variances both with adding and subtracting our distributions. So let's see what that looks like. It says Linda sells and leases cars. Same prompt. X is cars sold, Y is cars leased. And we defined D as x minus y. It says compute and interpret the standard deviation of D. Well, I already found the standard deviation of x. That was from the previous video. And I found the standard deviation of y using that same technique of the squared deviations times their probability. Well, if I want to find the standard deviation of D, look back at your formula. Does it say the standard deviation of x plus y equals the standard deviation of x plus the standard deviation of y? Or does it say the variance of x plus y? So when I compute and interpret the standard deviation, I actually have to find the variance first. So I'm going to find the variance of x and add it to the variance of y. So when I go to plug those in, the variance of their difference would be the variance of x Well, I'm given the standard deviation of 0.943, so I'm going to square that to make it a variance, plus the variance of y, 0.64. I'm going to square that to make it into a variance. And when I do that arithmetic, I get the variance of D equals 1.2988, or we can just make that 1.299. So this is the variance of D, or sigma squared of D, but does it ask for that, or does it ask for the standard deviation? It actually asks for the standard deviation, so the standard deviation of D is just the square root of my variance. And when I do that arithmetic, I get that my standard deviation is 1.14. So my final answer would be 1.14. That's the standard deviation, or the spread of my distribution. So just to recap, I found the variance first. The square root of my variance is my standard deviation. So this brings us to key point number 3. The more variables there are, the more variability or spread there is. So we add the variances together when combining two random variables. We never subtract the variances. And we also never add standard deviations together. So this is a super common mistake. People want to find the standard deviation, so they just add the standard deviations together. We can't do that. We have to make them into variances before we add them, because if you do the math, you'll see it gives you a really different answer. We have to square them to make them into a variance and then add them together. So make sure you get this down, that this has a big X in it. We don't want to do that, and it's a super common mistake. So don't fall into the trap of adding standard deviations together. So once again, Scholar, you've been working really hard, and I'm very proud of you for taking the time to watch this video and get prepared for class. So here's a little motivation. Go to this link, and I hope you're inspired. So that's a wrap. We can combine two independent random variables, and we can only combine variances, not standard deviations. So once again, section 6.2 in your book. Please look there for more examples and extra practice. I'll see you next time.